Hello everybody. In this video I want to cover some of the material that we're going to see in our report this week. Specifically, I want to start by talking about the section that is titled Identity of Metal from Specific Heat. So in this part of the lab, what we were going to do is have a boiling water bath here. And into it, we're going to add a piece of metal. We're going to let it warm up and thermally equilibrate. We're going to measure that temperature so we know what it is. We're going to take that piece of metal out. We're going to place it into our calorimeter. And we're going to see how much this water warms up in that process. So we're good scientists. We're going to take a lot of measurements here. So we're going to know the mass of that metal block. We're going to know the mass of the calorimeter while it's empty without the water. We're going to add the water. We're going to mass it again. We're going to know the mass of the calorimeter and the water. We know the temperature that our water bath was at. We know the initial temperature of the water in the calorimeter, and we're going to know the final temperature in the calorimeter after it's been heated up by the metal. First thing we're going to be asked for is going to be the mass of the water, and this is just our weighting by difference that we've seen quite a bit so far. We're going to take the mass of the calorimeter in the water, and we're going to subtract out the mass of the calorimeter. The next question that we're going to be asked is going to be for the temperature change of the water. We're going to take the temperature that it ended off at, final, minus the temperature of the initial. Next is going to ask you for the heat of the water. That's going to be the mass of the water we just calculated up here times the specific heat times the delta T that we just calculated. Now, it asks for this heat value in degrees and calories. And the value we're going to use for the specific heat is going to be 1 calorie per gram degrees Celsius. This is a pretty easy little calculation here. Now, we know that the heat of the metal is going to have an opposite sign as the water. One was cooling and one was heating, but Labflow wants to make this simple on us. So they want us to always enter positive values and not worry about the negative sign that we're going to see. And I just want to make a note that this is where you're probably going to run into some negative signs, and you're going to have to go ahead and put those in as positives. The next thing that they're going to ask for is going to be the change in temperature of the metal. So it has the same final temperature that the calorimeter water did, minus the initial temperature that it had, which was the temperature of the boiling water bath. Then we can calculate the specific heat of the water. It's just this equation right here, solved for specific heat. So that's going to be the heat of the metal that we got here, same as the heat for the water, divided by the mass of the metal that we did as a measurement times its change in temperature. And then you're going to be having a list to look at, and it's got a bunch of different metals on there and their specific heats. You're going to match this up to whichever one is closest when you do your calculations. In the next part of this report, what we're going to do is we're going to look at and do a little experiment to find the caloric content of some food. So in this scenario, you have a ring stand. That's what this thing's called. And you put a little metal ring that clamps on here. And there's going to be like some wire gauze here. And you're going to use that to hold up a metal pop can. Why we're doing it in a metal pop can, I'm not really sure, but I guess it's as good a vessel as any. And we're going to fill it with a known amount of water. We're going to measure the temperature. And then we're going to build a little doodad down here with the piece of cork right here, and there's a metal wire, and then you put a gob of food on there. And then you burn the food, the heat rises, and it heats the can up. This is a very crude sort of bomb calorimeter sort of setup. Our known variables, we're going to know the mass of the can. We're going to know the mass of the can plus the water. We're going to know the mass of the food initially before we burn it. We're going to know the mass of the food after we burned it. We're going to know the initial temperature of the water, and we're going to know the final temperature of the water. So first we're going to find the mass of the water using our massing by difference here. We're pretty comfortable with that at this point. We're going to figure out the delta T for the water by taking the final temperature we get minus the initial temperature. We're going to calculate the heat that the water gained by taking the mass times, again, that 1 calorie per gram degree Celsius times this temperature change. We're going to recognize that the heat gained by the water was lost by the food, but we're not really going to use that negative sign. We're just going to put the positive value in. And then we're going to figure out what mass of the food burned by taking the final mass of the food minus the initial mass of the food. And then we can calculate the calories per gram as that heat divided by the mass of food that was burnt. And then we're going to compare this value to what it says on the nutrition label, where you would take a serving size of so many grams, and you would take the calories that it says that is, and divide the calories in a serving by the mass of a serving. And then you're going to do another few calculations where you're going to calculate based on how many carbohydrates and fats and protein is inside of your food. We've done those calculations before. You're going to be using the same values we have before. 4 calories per gram for protein, 4 calories per gram for carbohydrates, and 9 calories per gram for fat. I'm not going to show that again in this video. If you don't recall, you should go back to the other unit where I did a video on energy and nutrition. And I think that's it. You guys should now know everything you need to finish up the report.